Hello, class. So we are now in section 2.2, which is about graphing. All right. Specifically functions. All right. So graphing functions. In this section, really, we just kind of want you to become familiar with some fundamental functions. Okay. So here I have a function f of x equals x squared. Okay. And kind of like what I showed when we graphed a couple of things in chapter 1. Something you can always do is just plug in. So if x is like -2, I can plug in -2 into my function and get 4. So then when I'm graphing, I can go to the point -2, 4 and put a dot there. And then I can just keep going. So if I plug in -1, I get 1. If I plug in 0, I get 0. So on and so forth. And then hopefully you connect the dots and we get this thing. Okay. And basically we would just like you to memorize that x squared looks like this. All right. Specifically this U-shaped thing. It's called a parabola. Okay. So x squared will look like this. And you can always plug in points. Now if we like add stuff and subtract stuff, then it'll look different. But this is x squared. Okay. Now the next thing is let's just go up 1 power. So x cubed. Okay. So again, I'm just going to plug in some stuff and see what happens. Let's not start with -3 though. Okay, so right, so that's 8. Actually, that's -8. -1, that's -1. 0 is 0, 1 is 1, 2 is 8. There we go. Okay, plug in. And so if I graph all of these points, 0, 0, 1, 1, 2, 8, -1, -1, -2, 8, we're gonna get this thing. Okay. So this shape doesn't have a name. It's just the cubic shape, I guess. All right, but x cubed will look like this. All right, and this is something else we'd like you to memorize. Okay, this shape. So x squared, parabola, x cubed, this thing. Okay. And then now let's think about this function. Okay, so square root x. Okay, now this is not a polynomial. Okay, so actually, right, like if I just mindlessly try and plug in some stuff, right, like -2, right, right, nothing happens, right? That's -2 isn't in the domain, so right, you got to remember that the domain of this thing is negative, well, it's 0 to infinity. Okay, I can't plug in negative numbers, so you shouldn't try. Okay, so I start with 0 because I want to know what happens, and it's 0. And then 1 is 1, and 2 gets me the square root of 2, which is not that nice of a point, right? Like you don't really know where that is. So you probably want to then skip 3 because it'll get you square root of 3. The 4 would get you 2, right? And then 9 gets you 3. So here's like a tip, right? Not all the numbers on the left that you pick, you can pick like pretty much anything as long as it's in the domain. But you probably want to pick numbers that after you plug them in are nice. Like 4 is 2 and 9 is 3 and 16 will get 4, right? Not like 2, right? 2 gets you square root of 2 and that's not that helpful, right? So if I plug these in, you're gonna get something like this. Okay, and notice over here, right, here's where like the negative numbers are, right? -1, -2, -2. Right, there's nothing here, nothing. Okay, and that's right. There should be nothing here because we can't plug in anything, so there should be no drawing. Okay. So that's the square root function, okay? We could talk about the cube root function now, but I'm gonna kind of skip that one. It's like not very important. And now I'm gonna kind of talk about big powers again. Okay. So here f is gonna be x to the power 4. Okay. Say x, y. And I'm just gonna plug in the same numbers that I almost always plug in. And what happens? You're gonna get 16, 1, 0, 1, 16. And right, if you plug those in, it's gonna look like this. So it looks kind of like x squared. Okay, just it's a little skinnier. And then I'm gonna try what happens when I do x to the 5th. So -2, -1, 0, 1, 2. What is that? That's 32. -32, -1, 0, 1, 32. So if we plug that in, it's gonna look like this. And if you notice, this looks like the x cubed. Okay, just a little skinnier. Okay, so this is always true. If you have a function and its leading term, okay, is even, so 2n, all right, it's gonna look U-shaped. All right, which later on we're gonna know that this means the function is even and y-axis symmetric. But for right now, you don't have to worry about that. All right, and if our function is leading term is odd, okay, then we're gonna get the like cubed shape. Okay, and this means it's odd, and this will mean it has origin symmetry. Okay, so this is just a useful fact, right? So like x to the power 6 is gonna look like this, x to the power 7 look like this, and so on and so forth forever. Okay. All right, now I want to introduce this function. Okay. So these we'll talk about much later on. These have their own section. Okay. But like f of x equals 1 over x. Okay. So remember, this thing's domain is not 0. Right? So I can't plug in 0. And like, right, if you tried, your calculator would error out. But like, let me plug in the other things. Okay, so like -2, -1, well, instead of 0, I'm going to plug in like 1/2. Okay, 1, 2. Let's just see what happens. So you see, I'm going to get -1/2, -1. When I plug in 1/2, I'm actually going to get 2. 1, 1/2. Okay, and maybe I should plug in more points like -1/2 and -1/3 and so on. But this is what this looks like. Okay. So as you try and plug in 0, it blows up to infinity and -infinity. And if you keep going, it actually is going to go to 0, right? Because like 1 over 100 is a tiny number, right? That's like 0.01, right? And if I just keep getting bigger, it just keeps getting tinier and tinier, okay? All right, so this is the reciprocal function, sometimes it's called, but 1 over x. All right, it does this. And we'll talk about this much later. You just kind of need to know this thing's shape for now, okay? All right, now one thing we can do with graphs, okay, which is important, is there is something called the vertical line test. Okay. So this is really useful to test, all right, to see if a relation is a function. Okay, so just if I give you a picture, you should be able to tell me if it's a function or a relation. All right. So here's an example. Okay. So I have my parabola. Okay, and how you perform the vertical line test is you kind of just draw a whole bunch of vertical lines. Okay. You can draw them anywhere you want. Okay. But we look at where it crosses the graph. Okay, so there. All right, and so you fail the vertical line test if a vertical line intersects the graph more than once. Okay, so if we look here, no matter where I draw a vertical line, this is never, right? They're never going to cross more than once. I'm only going to cross once. Okay, so x squared is a function. Okay, is function. This is good. All right. Now, though, if I do this looking thing, all right, which this is x equals y squared. But if I do this one, all right, and then I draw my vertical lines, right? Right. Pretty much any vertical line I draw, I'm going to cross more than once. So this fails vertical line test. Okay, so not a function. Okay, but it doesn't really matter if I cross right more than once in multiple places. Okay, so here I'm gonna draw this looking function. Okay, and like we see, if I draw my vertical line here, I'm fine, right? Or if I go here, it's also okay. But if I draw it like right there in like the middle, right, I cross 3 times. Okay, so this also fails vertical line test. Not a function. Okay, so you just need to fail vertical line test in like a single spot to be not a function. Okay, so this leads to this very famous trick question. Okay, like remember piecewise functions? So this is what happens if when you have like a piecewise function, your like rules over here both have equal to bars, right? But let me put like 1. So if they both had equal to bars, then right, you put 2 closed circles, right? So then when you do vertical line tests, you're fine, except in this one single spot, you would fail vertical line test. Okay, this is why the hole, okay, putting a hole somewhere and making sure that you don't have an equal to bar is very important. Okay, so this is why the hole is important. Okay. All right. So yeah, that's a vertical line test. All right, it's really easy. You should know how to use it. Okay. And then lastly, the last thing I'm going to talk about in this section, really doesn't matter at all. Not important. Not important. All right. If I had like regular online homework, like if this was a normal class, you would have like 1 question about this. So this looking thing, All right, so if you crack open your textbook, if you have one, you will see this looking function, and they call it the greatest integer function. Okay. Okay, and so the greatest integer function tells you the biggest integer, like it basically tears off the decimal part. Okay, so I'm gonna call this f of x. Okay, so f of 1 is 1, f of 2, 2, f of 3, 3. Okay, f of 0, 0, f of -1, -1, f of -2, -2. So you see, like it's not doing anything, right? So if you plug in a whole number, nothing happens. Okay, but now, so right, f of 0 is 0, but f of 0.1 is also 0. F of 1/2 is 0. F of 0.999999 is 0. Okay? But f of 1 is 1. Okay? And then I hope you kind of see this pattern of like f of 0.00001. That's 1. F of 1.5 is 1. F of 1.9999999. That's 1. Okay, so it essentially chops off the decimal. Okay, and it has this very funny looking graph that some of you might be getting like some PTSD to high school. It is closed circle, open circle, closed circle, open circle, closed circle, open circle, and it looks like this step function. All right, it's these steps. Okay, so this is what the greatest integer function looks like. Really, it's not important. Maybe for your job, if you ever go into like an analyst position, floor might be useful. So it's also called floor. And this is what it looks like to normal people. All right, I don't really know why it has this special symbol and this special name, but in reality, it's also just the floor function. Okay. But that's it for section 2.2. It's not that bad. All right. See you guys next class.